So in this video I'm going to start to talk about what makes a good 3D scanner, and there is a lot of offers on the market, and for amateurs, it's even for advanced amateurs, it's sometimes difficult to judge which system to purchase. So most of the scanners are as well not available for testing, and it's something really different if you use it on your own or if you are getting presentation with things that are really perfectly prepared and everything looks fine, and you take it home and take it out of the box and you start working with it, realizing that it's somehow of a fraud. So it's not let's say so bad like it had been in the really beginning of the 3D scanning, but still it's good to have some information about what you have to look on. The topic today is temperature compensation. That's a very big problem for many projector-based scanning systems, and this is not an obvious problem, because you will just realizing it when you are working with complex closed volumes, because temperature compensation, if it's not done properly, will cause that your 3D scans, each of them that you melt together to a model, are deformed slightly. And if you have a bigger deformation, it will lead to the fact that you will not be able to create a proper volume, because the deviations from each of the scans will sum up and you will have a messed up model. So geometry will be deformed. Sometimes it can happen that even the software is not able to merge it to some volume, because that algorithm says, yeah, there is big deviations, this is not a volume, I will stop working. And you maybe spend I don't know, 1-2 hours scanning a car or a motorcycle with a lot of spraying and everything, and you will be really pissed off because you have lost your time, ending up realizing that the result will not be able to be calculated. So yeah, make sure that your temperature compensation in the scanner is working fine, and you will already have an indication if you bought a good scanner. So when I first had to face the problem that I'm talking about, it was in one of my very first systems that I bought for 3D scanning. It is some years ago, and this times David SLS was, for many amateurs, it was, let's say, something really cool, because it was one of the very first structured light systems that had some capabilities, and that was affordable actually. Nevertheless, I was never really satisfied. Maybe I will do some video over my history in 3D scanning. It can be really interesting what have changed over the years, but so far I was always having problems with preciseness in merging complex scans with a lot of views actually. And by the time I was questioning myself, what can be the problem actually? Why is it really a problem that when I merge two scans, that they not fit together like they should actually? The shells, they had always problems in the overlapping areas from one scan to the other, and after some time I started to realize the problem actually, and I started to make some temperature test scan row actually. So I opened that very old project that fortunately I didn't delete it even after selling my equipment over the time. Actually, I downloaded one of the later versions of the software that was given to HP after David sold their business actually, and I will show you in the wrong color analysis what it means actually. This is the view of the calibration board. That was a calibration board compared to others that was like a book open in 90 degrees. There were two walls with points on it, and after calibrating the scanner, I was shooting one view of that board without changing anything, and I was shooting in the time ranges that you can see here in the naming, from the same situation, same view, shooting the very same picture over the time and comparing the results with each other. So I was able to see what happens with the picture that should stay exactly the same over the time, and if it's like that, actually, if it's bending somehow, and you will see what will happen. So actually I will start with the 5 minutes view that I created, and I will compare it with 10 minutes view. Let's see what it happened. And you can already see that the change is quite big actually. So this is the deviation color analysis, and that means everything that's above the violet areas is bigger deviation than 0.1. So you can already see as well in the negative way, the positive way, sorry, that was the negative one. Everything that is blue is bigger than 0.1 in the other direction. So compared to the surface before. And I started to get a clue what can be the problem actually, and you will see that it's not getting better over the time. So we'll compare it with the shot that I did 25 minutes later on. And you see the area is getting bigger actually. So I can continue like this for more time, but maybe you got it what actually happened. So the equipment was built out of a very reasonable industrial camera and some home projector actually. That was some, I think it was HD standard resolution, some Acer, or I'm not sure what it was in this time. They changed the projector over the time, and the equipment isn't temperature compensated, so the plastic lens in the projector, what is not professional equipment like in other scanning systems, and the lens sensor itself, they will heat up and they will change their shape, even positions will change over the heating up, and you will create deviations in the system itself. It seems to be very small what you will get in deviation regarding to a temperature rise over the time, but actually it have a really big lever because the lenses are very small and the objects are far. So a very small change in the lens shape or in the behavior of the sensor can really create huge changes. It's like a very big lever. If you imagine the light ray coming to the system, bending it a little bit through that lens, it will create very big deviation. So I will sketch it maybe one time, the problem, because it will be topic of more problems in other areas. And nevertheless, a very small deviation in the way how the light is processed will really lead to really big problems actually, because everything is quite far away and the sensor itself is very small. So after heating up for some time, it was getting better a little bit. We can see that I was comparing here 60 minutes with 35 minutes. And you see, after some certain time of heating up, the problem was getting smaller, I guess. The problem that I seen, that it was coming into some stability after 1 hour of heating up. For every guys out there who are still using that system, what is really still not bad actually. It's for a very reasonable price on the market. The resolution is not so small. Just one hint from that time when I was really getting angry quite a lot because of the results that didn't merge very fine. heat that system up, and at minimum 45 minutes, then do the calibration. Heating up means, let's say, put on the camera to the laptop, switch on the projector, and use not the black image, because that will in the projector create some different thermal situation. Use some test picture with a pattern and leave it like this for 30-35 minutes, just without doing anything. And afterwards you use the calibration board, do your calibration in the heated up situation, and you will be much better off actually, compared to if you start to connect all your devices, do your calibration and start to scan, because you will over the time have a very big geometric deviation created by the system from each scan, and you will face up a model, for example on a turntable, that have bended shells compared to the original, and it, for example, will not close anymore. So you will have the problem that you will have a full scan 360 degrees, but the software will not be able to merge it to full view, because the deviations will cause that the ends are not matching up, and the software, depending the system, if it's scan in a box or other ones, will do something, and it might work or might not work. It's not so different. You will create really deviation. Scan in a box, I didn't test it on this behavior. Just do it. It would be really cool if someone have it, and put your comments below. But I'm expecting similar problems actually, because not many systems are compensated regarding the thermal problems. So after stepping away from David SLS scanners, we were in search always for finding good solution for portable scanners, because with their turntables they are very useful for digitalization of higher quantities. And we tested several systems, and as they are looked from the first look, or looking from the outside without having any kind of the special informations, they look quite similar, because they all have industrial cameras, some projectors with more or less HD resolution. It took some time to really identify what is worth the money, and we ended up as well cooperating with Range Vision, because in the first test we already realized, that was some years ago, that their software is really good. And in the last test I really have to say they was correcting the last few things that wasn't perfect, and I got to say, for the money, it's in this moment in the price range around 5,000 euros for portable scanners, it's the best buy. So we bought a Spectrum, and I did the same test on the Spectrum. Unfortunately, I don't have this plate from the David scanners anymore, so I'm not able to do the exactly same test, but I'm using a cube that it's not too small, and I'm going to place it inside the view, so it's covering a big amount of the scanning area. So I'm going to be able as well to see the three-dimensional behavior, because it's a cube that's positioned slightly turned. So referring on the experience I was showing you before regarding the temperature scan row with the David SLS, we are going to do some nonlinear steps with the Range Vision scanner as well, because heating up these technical devices is having a bigger temperature gradient in the components in the first minutes, and they are staying more stable after some time. So the first step is 10 minutes, then 20, 30, 40, 1 hour, 2 hour step, and a step in 3 hours. So again, like in the analysis of the results from the David SLS results, we are analyzing the deviation between the scans over some color analysis, so wrong color analysis, however you like it. So the deviation from green means deviation from 2 scans that was done to each other. That means distance deviation. So if you have blue or red colors in that picture scene, it means that there is a deviation from one model to the other. So in this case, I'm, let's say, comparing in several steps the scans, and the first scan that you have here on the list of the scans is always the cold scan before any kind of the heating up, and after that is coming the time steps, 10 minutes and so on, like I explained before. So the first comparison is between the scanner in cold condition and after 10 minutes heating up. You will see that really looks good. Then the second comparison that you will see is between 20 and 10 minutes as well. It's fine. If you make the steps bigger, like in the third comparison, you have a comparison between the scanner in cold condition and 30 minutes of heating up. So there's already some really relevant gradient in heating up, so you will have for sure some influence on the components. And fourth comparison, you have cold scanner compared to the 40 minutes heating up scan. It looks fine actually. You have not the same behavior like you have seen it in the David scanners. And even if you compare the cold scanner to 3 hours heating up, what is comparison number 5, you are still really in some reasonable area. So that means for sure in this software is implemented a temperature compensation of the result. That means there was made a very let's say sophisticated calculation about how the components will change, and there was a thermal correction in it. And sixth comparison is between 1 hour, 3 hours, and seven and last comparison is 3 hours and 40 minutes. I didn't continue to present the results because it makes no sense. It's just theoretically, and you will see that the comparisons show that there is a really small deviations. You see that in the cold scanner to 3 hours comparison, there seems to be some minor effects as well, like most of the scanner have it in the three-dimensional field in the depth. I guess there is some really small areas where you could imagine that there is a deviation. I think it's not a really big problem, but if you want to have the best scan results, like in the David scanner explained before, warm up your scanner some, let's say, half hour or 40 minutes, whatever. That means leave the scanner in operatable mode, as well projecting the pattern that will be used later on, because in DLP scanners different colors, for example black or anything, can have different thermal influence. And this is the precisest way of measuring. After half an hour, 40 minutes, you calibrate your system and you scan, and you will have the best results possible on your device. So I think in this portable scanners it's like some rule. Of course other scanners have some more complex temperature compensation. They will have even less effect. That means they have cooling fans and so on. But this software compensation that is realized in range vision, I got to say it's really great. It's much better than what I have experienced in the David times. Of course you have to see David was a long time ago. It's I don't know, 10 years more when this was a current system, but it's still in the head of the people, and it's still usable and have really some benefits. But this is for us the reason why we chose range vision, and I hope that was something that you appreciate, that we show you what is the differences between the different systems, because you will face that there's a lot of systems on the market and it's really difficult to figure out which of them are working fine. We chose them after testing I think 5 or 6 systems over the years and companies, and decide let's say, Shining, we are, let's say, really happy with them. They have a different profile of the devices. That's why we combine both of them, because we don't want competition in between the devices. But I can really recommend with, let's say, good conscience that you can buy this device. The spectrum is really good. We purchase it if you're interested in, so you can write us. And if you have further questions, please comment below. If there will be same questions popping up more times, we are going to make video on that.